Hello everyone. In this video, we will continue to examine topic 1.2, uncertainties and errors, and in particular, we will continue to unpack the absolute, fractional, and percentage uncertainty representations. All right, in the last video, we described the absolute uncertainty as being sort of the default way of representing an uncertainty. It's an uncertainty represented in the units of the quantity. So 21.3 plus or minus 0.5 meters and 1.23 plus or minus 0.15 seconds are examples of using absolute uncertainty, representing absolute uncertainty. Note that the guidance here will be super crucial moving forward. When you represent that uncertainty, you should use no more than two significant figures in the representation of the uncertainty, and then the number of decimal places in the answer, whatever the value is, should match the uncertainty. That is, the last digit in the uncertainty should also be the last digit to which you represent the value itself. In IB notation, the uncertainty is represented as x, for whatever the value of x is, plus or minus delta x. A quick word on that. So the IB uses delta x here, which I think is just an abomination of a piece of notation. Delta in every other context means change in, and hopefully you've rewired your brain to read a delta as change in, but unfortunately that's not what it means in this case. Everybody else in the world is going to use a sigma or another variable to represent the uncertainty. They certainly don't use this capital delta here, but that's just the way it goes for us. So I will use delta x to mean the uncertainty in what follows, in order to match your data booklets and to match the IB representation. You should know that nobody else will do this. They will use a lowercase delta like this or a sigma in order to represent uncertainties. All right, so question. Absolute uncertainty is pretty good. It's almost always what we want, but it actually doesn't tell you very much, and here's why. So if I tell you that the uncertainty on my measurement is plus or minus 0.5 meters, and then ask you, well, was that precise or not? You don't have enough information to answer that question. Is 0.5 meters, plus or minus 0.5 meters, is that precise? Well, I don't know. Are you measuring the radius of the Earth? Or are you measuring your height? If you're measuring your height and you're off by half a meter, I would say that you are a terribly imprecise height measurer. But if you are measuring the radius of the Earth and you are off by half a meter, I would describe you as having done a shockingly good job. In the first case, even though the absolute uncertainties are the same, the uncertainty is huge on the measurement of your height. But the uncertainty is absolutely minuscule on the measurement of the radius of the Earth, even though the absolute uncertainty is the same size. The concept that captures the difference between these situations is the fractional or relative uncertainty, sometimes represented as a percentage in the form of the percentage uncertainty. And the way this works is that if you have an absolute uncertainty and you simply divide it by the quantity itself, that gives you the uncertainty expressed as a fraction relative to the original measurement. So if your uncertainty is, for example, 0.5 meters on a measurement of 21.3 meters, then that is a fractional uncertainty of 0.02347, rounded to two significant figures, plus or minus 0.023. Notice that a fractional uncertainty, because it is measuring the uncertainty in the units of the measurement divided by the measurement itself, also in its own units, is unitless. So a fractional uncertainty, unlike the absolute uncertainty, is a unitless quantity. Notice that the percentage uncertainty, often, we're more interested in the percentage uncertainty than the fractional uncertainty, but the percentage uncertainty is just this fraction represented as a percent. So, for example, in the previous case, 0.5 divided by 21.3 is 0.023, or plus or minus 0.023, but we'll almost always represent this as a percentage. That is plus or minus 2.3%. And so you can often quote your value as 21.3 plus or minus 2.3%. Notice that as a percentage or as a fraction, it gives you an idea of how big the uncertainty is relative to the measurement. It will capture the difference between a half-meter uncertainty on your height and a half-meter uncertainty on the radius. So the same uncertainty can be represented in these three different ways: this absolute uncertainty, the fractional uncertainty, and the percentage uncertainty. And notice that you can go from one back to the other because the fractional uncertainty is just equal to plus or minus delta x over x, and the percentage uncertainty is just equal to plus or minus delta x over x times 100%. You can go from these back to this if you want to, or vice versa. In different situations in the IB, you will be asked for all three, and you should consider which makes sense in different discussions. Absolute uncertainties are super useful when you want to actually give a measurement or use a particular value. And you'll find that fractional or percentage uncertainties are more useful when you wish to discuss the relative precision of your measurement.